Okay, so we have built a logistic classifier. So far we have built a k nearest classification, and then we have support vector machines. Now what we are trying to understand here is which one to use, and when and how efficient are each of them. So we start with the concept of decision boundary. Now what is exactly a decision boundary is in a logistic regression or any of the other machine learning algorithms is the line, or is a hypothetical hyperplane which classifies one class from another. Now what is the decision boundary in a logistic regression? Remember, logistic regression spits out a probability, and then we have a particular score set as a cutoff based on which we classify them to be 1 or 0. Essentially what a logistic regression would look like, if we were to have a data set of something like this, it would be a straight line. Please remember, it would be a straight line because the end result is the classified label that we kind of put to the predicted data set. We put them in either one of the classes. That's all we try to do, and hence based on the probability score and our cutoff, we try to label it 1 or a 0. But then how about what would be your decision boundary in case of SVM? We have already discussed an SVM would have a decision boundary of that of a hyperplane. Now how would that look like? So in that case, we have already said it would pick the closest data points and then build a hyperplane maximizing the distance from each of them. So it will minimize the distance between the data points, and then it will build a plane which is at the greatest distance from each of them, which means it will be at the perpendicular from each of the closest data points. And in that case, our SVM kind of predicts or builds a decision boundary which is much more flexible and agile, and it can it can take any sort of a shape. So that's why that's the greatest asset for an SVM classifier. Because of this reason, any data set we are able to classify it with a better accuracy. And hence that is the greatest strength for SVM. Again, for decision tree, I think that would be multiple perpendicular lines based on which you would try and build, but still the accuracy for a decision tree would be, as you can see, you would have certain data points not fairly well classified in that case, because it builds multiple perpendicular lines and then flows on. I kind of hope this is a quick kind of a help for you guys to understand and imagine how and based on the decision boundary, how the efficiency of a particular model depends on. So that was a quick one for you to be able to understand and visualize the decision boundary, and hence what your each of the models would look like. See you on the next one. Thank you.